Today our lecture is about the Venn diagrams, right? So we start from 18.2 Venn diagrams. The relationship between different sets can be illustrated by the drawing Venn diagrams. So basically the Venn diagrams are the pictorial shapes of the sets. We can show our sets in the form of pictures, and this diagram is called Venn diagrams, right? After that, in the Venn diagram, each set is represented by a circle or oval shape. So when we are dealing with the Venn diagram, a single set is represented by a circle or oval shape contained within a rectangle. So all the sets are into the rectangle. And what is rectangle? Rectangle is basically the universal set. As I have explained in previous class, this universal set is the set in every specific question or example that is the biggest set in that example, right? Or in that time. For example, this is the example now, and you can see that the rectangle is greater than the set A and set B. It means that rectangle is a universal set. Depending on the elements the set is, it might be appropriate to have the sets overlapping, or even for one set to be completely contained inside another. So these are the cases. The cases are that first case is that the two sets are intersecting each other or overlapping. Overlapping means that one set is here. Let's suppose this is set A and the other set is overlapping on set A. It means that this case is overlapping. Now this small region is overlapping, so that is called the overlapping of sets. The next one is that, or even for one set is to be completely contained inside another. It means that, let's suppose here we have the set A and the set B is into the set A. So that means that it is completely contains inside the set A. So you can see that I am drawing the sets, but all the sets are in the form of circular shape, right? These examples show some of the possibilities. So here is the first example which can understand better. For example, this is the universal set, and a universal set contains the positive integers less than 20. It means that 2, 4, 6, 8 up to so on. Less than 20, it means that till 18, right? Set A is 3, 6, 9, 12, and set B is 5, 10, 15. If you are writing this set A in the form of rule, you can write it as the multiples of 3 less than 15. And if you are interested to write the set B in the rule form, so you can write it as the multiples of 5 less than 20, right? Or you can also say that the first three multiples of 5. It's up to you. Okay, after that we move forward to the solution. Since there is no element common to both A and B, first of all we draw a rectangle that shows a universal set, and these two sets, as you see that the no one element is common in A and B, so it means that there is not any overlapping. So A is this one and B is this one. So this is the set A and this is the set B. This is called the Venn diagram of the given sets. Since there is no element common to both A and B, there is no overlap between two sets. This is the Venn diagram. Do you understand this Venn diagram or not?
Yes.
Okay, good. Next example is same like that, but here is a smaller difference. Here the universal set is all positive integers. It means that from 2 to infinity, all positive integers. So this is a very bigger set. This is universal set according to these two sets. So A is 2, 4, 6, 8, 10, and B is 5, 10, 15, right? Illustrate these sets with the Venn diagram. So you can see that something common in these two sets. Yes, this is 10 in both sets. So it means that a small region can be written by using the overlap method. So it means that A and B are overlapping. Since 10 is in both A and B, there is now an overlap between the two sets. So we can draw its Venn diagram like that. Do you understand or not?
Yes.
Okay. The third case is given in the next, but we'll study after studying this point. A set P is a subset of an other set Q. P is a subset of an other set Q. This is the notation. If every member of P is also the member of Q, let's suppose we have 1, 2, 3. This is a set A, and we have a set B that is 1, 2, 3, 4. So these are two sets. If A is a subset of B, A is a subset of B, it means that every element of A contains in B. Again, if I write the set's name as P and Q, then you can easily understand. A set P is a subset of Q if every member of P is also a member of Q. Do you understand?
Yes.
Okay. Subsets should be illustrated on Venn diagram by drawing them completely inside the set. So if you are drawing a subset into the Venn diagram, the subset is completely inside the bigger set. For example, this is your bigger set Q. If you are drawing the subset of Q, that is P, so you can write it as this is the subset of Q, that is P. Understand? So this is the pictorial form of the subset. Venn diagram by drawing them completely inside the set of which they are a subset. The notation is P is a subset of Q is used to write P is a subset of Q. So this notation is used for P is a proper subset, right? And this is used for P is a subset. Proper subset means that uh, P contains at least one less element than Q. So it means that P is a proper subset of Q. If P and Q are equal, so they are, you can see that they are subsets of each other also. Okay? Do you understand?
Yes.
Okay. Next is the example. The universal set is given all positive integers. A is equals to 1, 3, 5, 7, 9, 11, and 13, and B is 1, 3, 5. C is all prime numbers. Illustrate these sets with a Venn diagram. So first of all, set A is 1, 3, 5, 7, 9, and 11, 13. Set B is 1, 3, 5. Set B is completely contained in set A. You can see in this figure. So it means that B is a smaller set that is into the set A, right? So this is called B is a subset of set A. First look at first set A and B. Every element of B is also in A, so B is a subset of